The mysterious interstellar object known as 3I/Atlas has once again ignited global curiosity, debate, and speculation, ranging from legitimate scientific inquiry to extraordinary claims of alien technology. But according to renowned theoretical physicist Michio Kaku, the unusual properties of this object are far more likely rooted in cosmic age and chemistry than in extraterrestrial engineering. Speaking on NewsNation Prime, Kaku offered a grounded scientific interpretation of the object's anomalies, pushing back against more sensational theories circulating in both academic and public circles. While acknowledging that 3I/Atlas is indeed unusual, Kaku emphasized that unusual does not automatically mean artificial. 3I/Atlas has drawn intense attention because it does not behave like a typical comet observed within our solar system. Traditional comets, icy remnants left over from the formation of planets, usually develop a bright tail as they approach the sun. This tail forms when solar radiation heats the comet's surface, causing volatile materials like water ice to vaporize and stream behind it. But 3I/Atlas defies this expectation. Despite passing relatively close to the sun, the object shows little to no traditional cometary tail. Even more puzzling, spectroscopic analysis has revealed the presence of nickel emissions, an element rarely observed in such abundance in known comets. These characteristics prompted Avi Loeb, a Harvard astrophysicist known for his willingness to challenge orthodox views, to suggest that the object may not be entirely natural. Loeb has publicly raised the possibility, carefully framed but widely amplified, that 3I/Atlas could be an artificial probe or technological relic of an ancient extraterrestrial civilization. Among the anomalies he cited were the lack of a tail, the unexpected chemical composition, and what appeared to be a change in velocity as the object passed near the sun. To many in the scientific community, these ideas tread dangerously close to speculation without sufficient empirical grounding. And this is precisely where Michio Kaku draws a firm line. According to Kaku, the most important and often overlooked factor in understanding 3I/Atlas is its age. Most comets humans have studied are believed to be between 3 and 4 billion years old, roughly matching the age of the solar system itself. But 3I/Atlas is an interstellar object, meaning it originated outside our solar system and has been traveling through the galaxy for an unfathomably long time. This is a very old object, Kaku explained, perhaps 7 billion years old. That distinction alone changes everything. Over billions of years, an object drifting through interstellar space would encounter vastly different environments, stellar winds, radiation fields, supernova remnants, and molecular clouds rich in exotic elements. Unlike comets locked into stable orbits around a single star, interstellar objects are cosmic wanderers, continuously exposed to new conditions. Kaku argues that this prolonged exposure could naturally account for the object's strange chemical profile. The nickel content is off-scale, he noted, but that doesn't mean it's artificial. It means it's had billions of years to accumulate different gases, different elements, and experience different environments. In other words, the chemistry of 3I/Atlas may not match that of solar system comets, simply because it was never part of the solar system to begin with. This explanation also offers a plausible reason for the lack of a traditional tail. If the surface composition of the object has been altered by prolonged radiation exposure, or if volatile materials were stripped away long ago, the typical outgassing process that forms a comet's tail may no longer occur in the same way. Another point of controversy involves the object's apparent increase in speed as it passed near the sun. Some observers interpreted this acceleration as evidence of propulsion, an idea that quickly fueled headlines suggesting alien engines or controlled maneuvering. Kaku strongly disagrees with that interpretation. There could be many reasons for a sudden spurt in velocity, he said. One possibility is that a fragment of the object broke away, altering its mass distribution and trajectory. Another is uneven outgassing, where material is released asymmetrically, creating a natural push similar to a jet, but entirely non-technological in origin. These things happen with comets, Kaku emphasized. That's not a smoking gun. As the debate continues, one area where both Kaku and Loeb agree is the need for transparency. The object was closely observed by NASA, which reportedly captured high-resolution images on October 2nd. However, much of this data has not yet been released publicly. Loeb has urged NASA to make the information available so independent researchers can analyze it and draw their own conclusions. Kaku supports this call, not because he suspects alien technology, but because open data is essential to scientific integrity. Speculation is fine, Kaku said, but you have to quantify it. You have to say, what is the level of confidence? Is it 1%? Is it a fraction of a percent? Otherwise, you panic the public. This distinction is crucial. Science advances through hypotheses, but those hypotheses must be grounded in measurable evidence and clearly communicated uncertainty. When extraordinary claims are presented without clear probability estimates, they can easily be misinterpreted by the public as established fact. And the public response to 3I/Atlas has shown just how quickly that can happen. Social media platforms, online forums, and even some mainstream outlets seized on the more sensational angles of the story. Headlines questioning whether the object could be an alien craft spread rapidly, often without the scientific nuance necessary to contextualize such claims. Kaku warns that this kind of coverage can erode public trust in science. The public wants to know the truth, he said, and the truth is usually more subtle, more complex, and less dramatic than science fiction. As 3I/Atlas continues its journey, it is expected to make its closest approach to Earth around December 19th before exiting the solar system, likely never to be seen again. NASA has stated unequivocally that the object poses no threat to Earth. For scientists, however, the object represents a rare opportunity, a natural probe from another star system that offers insights into the broader galaxy beyond our own planetary neighborhood. To Michio Kaku, that alone makes it extraordinary enough. This is a chance to study something truly ancient, he has suggested, a messenger from another part of the galaxy, and we should approach it with curiosity, rigor, and humility, not fear. In the end, 3I/Atlas may not be an alien spacecraft. It may not be a technological artifact, but it is a reminder of how little we still know about the universe, and how careful we must be in distinguishing wonder from conjecture. As the data continues to be analyzed and more observations come in, the mystery of 3I/Atlas will likely settle into something more familiar. A rare, ancient interstellar visitor, shaped by time, space, and physics, rather than by intelligence. And in the vastness of the cosmos, that may be just as awe-inspiring.